Welcome to a new Geometry Notes tutorial. It's been a while since I made the last Geometry Notes video, but of course there's new things added all the time, new features and new nodes, and we're going to look at one specific node today, and that's the Raycast node. So I recently watched a tutorial from Erindale. You have to check out his channel. I'm going to link it down in the description. He does all sorts of cool procedural, parametric, crazy math stuff in Blender. It's really awesome. So he made a video about camera culling, and in that video he used dynamic paint. So he created this sort of a cone of the field of view of the camera, and that would be painting on the surface, like the brush, that's the brush, and then the canvas of the dynamic paint is where that brush intersects with the canvas, and then that would be the weight paint where you place your particles or whatever you want to instance. And in this tutorial we're going to use that new Raycast node and also create camera culling, but 100% geometry nodes. No dynamic paint needed whatsoever. So I'm glad you're here. I hope you're excited. Let's jump right in and let's do this. Alrighty, here I am in Blender. This is 3.0 alpha latest download from I think yesterday or 2 days ago. Oh, by the way, let me just show you, if you've never seen this before, it's called Blender Launcher, and if you, like me, like to download the latest versions and play around with different versions, you can have stable, daily and experimental. And if you go to daily downloads, this is the latest thing you can download, July 1st, 21. You just click download and then it shows up in your library and you can start it. And so the last version that I have here is from June 29th. If you want to try Cycles X, for example, you go over to experimental, download, you find Cycles X, click download. It shows up in the experimental library, and then you can try out Cycles X, which is really awesome. And it takes care of all the versions on your hard drive. And if you don't want one anymore, if you don't need it anymore, like whatever this 3.0 alpha from May, you just right click and you delete from drive and it's gone. It's really awesome. Blender Launcher, I'll link it down below. It's free. Cool. So what is this new node? Here I am in my default startup file. I've deleted some stuff, so I only have my stage here. And down here we have the geometry nodes. So first of all, let's put in something, maybe a monkey. Let's put Suzanne in the middle here. Okay, so geometry nodes, the Raycast node. Here I am in geometry nodes. I'm gonna create a new node tree, and I'm doing this on the background, okay? So Shift A, we can do Raycast in the geometry menu here, Raycast. This is the new node. So let's check out what this node does. First of all, it works this way. So you have geometry, like points or vertices of your mesh. And this Raycast node shoots out rays in a certain direction from each vertex. And if that ray hits something, the target geometry that you can plug in here, then it sets an attribute. You can define the attribute here. If is hit is like a Boolean, does it hit or not? You also get the hit position. You can put that in an attribute, or the distance. Here you can define the ray length. So it's all by default it's 100 meters, goes really far. This is the direction. It's a vector. By default, it just goes 1 on the Z, so all the rays are pointing up. Let's see if it works. So first of all, we need Suzanne in our geometry node in here. So input object info. Let's pick Suzanne and plug that into the target geometry. So of course we haven't changed anything yet. Remember, we are on the background here, okay? And the geometry node that I created is on the background. So the background is emitting those rays. And if it hits Suzanne, we want to set is hit. Let's just plug that in here, create a new attribute, call it is hit. So now the geometry here has this attribute. We can actually view this with our spreadsheet. So here you can see each vertex of my background here. These are the positions of the vertices. now has this hit attribute. Okay. Now the geometry that I have on my background here looks like this. So it's not very detailed. We only have details in the curve here. So first of all, I need to add some more geometry. I do that by simply going in here and adding maybe go like up here first, add a whole bunch of new loop cuts, and then on the X as well, create a lot of geometry. So now this would be our resolution, right? So the background now has a lot of geometry. The list here is very long, and you can see there's some Boolean truths here. So like this. So it's already working. It's setting the isHit wherever a ray is hitting Suzanne. But of course, this is kind of boring. We can't see what's happening. And there's also a new node I'm just going to show you just for demonstration purposes. We have material nodes in here now in geometry nodes. And we can do material assign. So I'm gonna assign, I don't know, the white graph paper. So by default, it's this green material. And the selection should be isHit. And you can see it's working. So there's rays being emitted from all the vertices, and they all go upwards, straight up. And if a ray hits Suzanne, then that vertex on the ground plane gets the isHit attribute set to true, and wherever that attribute is set to true, I'm setting the vertex color basically to the graph paper. So now we're projecting Suzanne onto I think I have to do the relative. So if I move Suzanne, yep. So now you can see this sort of pixelated projection of Suzanne onto the ground plane, and the pixels come from the resolution of the ground plane. Okay, makes sense. So if I go back to my background, and if I were to emit my rays on the y-axis, but a -1, so set this to 0 and set this to -1, then I get the projection on the back there. So if I rotate Suzanne, you can see we get that sort of thing. Remember, we're working on the background. The background is now emitting rays going forward, and wherever they hit Suzanne, the background vertex gets the isHit attribute set. So this is how the Raycast node works. It's a really cool node. I'm not sure why it's in geometry node, but it's a cool node nonetheless. So let's see what we can do with that. And like I said, what we want to do is camera culling. So what is camera culling? Let's, for example, you know what? I'm gonna get rid of Suzanne. I'm gonna add a new, let's do an icosphere, move it out of the way, and scale it down quite a bit in edit mode. And we want to distribute this icosphere all over our geometry. So let's clean this up here. And let's do a point distribute. We want to distribute the random density, maybe increase that a bit. And then we want to point instance that icosphere over there. So now our background looks like this. The background itself is gone. If you want to bring that back in, let me just make this bigger for the video here. We can always do join geometry. This is our original geometry, that stage background. We plug that back in, and then we have the stage and all the icospheres. So maybe I set this to something like 15, and you can see we have all the icospheres and the stage. Okay, now let's do camera culling. So what is that? Let's look over here. Let's look through the camera, and you can see the camera is only looking at, or the camera would only be rendering this square because I have my output set to 1080 by 1080. Okay. Now, of course, geometry nodes of that background object has to do all of that distribution, but we can only see that part. So why even bother creating all of these particles, let's call them? And that's what basically camera culling would be doing. We would only be distributing our objects in the area that is really visible by the camera. And we can ignore the rest. This increases performance during work in Blender, in the viewport, and during rendering. So that's the goal. How can we do that? So we know that we can click on our background and we can use that geometry Raycast node. And we're just gonna plug that in here. Now that geometry Raycast node is emitting rays in a certain direction. But that's not what we want here. We want all of the vertices, each single one should be emitting a ray towards the camera. Can we do that? We can, because we can set the ray direction not to a single vector, but instead to an attribute. So now ray direction could be an attribute. Can we create an attribute for each vertex that points towards the camera? Of course we can. We take input, object info. What do we want? We want our camera, this guy. The camera has a location, and if I look in here, where's my camera? Oh, here. So the camera location would actually be this point back here, a little orange dot. That's the origin of the camera. Okay. Now let's click on here. So how do we get the a pointer from the vertex, each vertex, to the camera? Well, we just need some attribute, vector math, right? So we should plug that in here. So we have the geometry, each vertex of our background. We are gonna do subtract the location. So we need a vector location from the position attribute of each vertex, and we're gonna plug that into camera. So our new attribute is called camera. Let's see if it works. Spreadsheet. Let's look at this node. Here we have a camera. It is a vector, and it's pointing, hopefully, towards the camera. Cool. Now we can use that in here. Camera. So now each ray is not just pointing, or all the rays are not just pointing all in the same direction. Each ray from each vertex is actually pointing towards the camera. Okay, but now we also need a target geometry, right? Those rays aren't hitting anything because we didn't plug in a target geometry. Well, what are we interested in? We're interested in the rays that are hitting the camera, that are inside of that field of view, like cone of the camera. And really the easiest way to do that is like this. Let me quickly hide my stage just to avoid clutter. And on my camera here, I have a track 2 constraint. I'm gonna switch that off real quick and take the camera and hit Alt-GR to bring it back into the center and pointing straight down. Because this makes it easier for me now to do the following. I'm gonna hit Shift-A plane, go into edit mode, scale it down, and maybe in side view, bring it down and put it like right there. Okay. Go back to edit mode and make it exactly the size of my camera here. Now, of course, I can move the camera and that plane stays where put, and we don't want that. So let's click on the plane, shift, select the camera, Control P and parent. And now if I move the plane or the camera, or if I rotate, that plane is always stuck right there. Now we can't see anything anymore except for that plane. Let's call that plane lens, right? So that will be the lens that the rays have to hit in order to be in the picture. And we just simply hide it from the viewport, and we hide it from the render. Or maybe let's keep it in the viewport and set it to viewport display. Let's do wire. So it's still there, but we can see through it, and we don't have it in the render, so that's perfect. Now I can go back to my camera, go back to my constraints, enable my track 2 constraint, and maybe also make the stage visible again, and bring the camera out again like this. Maybe closer. So again, all we really want to see in this camera view over here is what's inside of the view. So let's go back here, and we need our lens object that we just created. So let's get the input object info. Let's put in lens, that is that plane in the front of the camera there. And that's the target geometry. Now, if is hit, we just put that in is hit. And we will use that to mask out the particles that we don't need, or the instances. I like to call them particles because they look like particles to me. And how can we do that? Well, we can do a point separate node. So here we have all the point distribution here, this guy, and here we're gonna mask is hit. And let's see, is that working? Redirection to camera. Now let's see, why isn't this working? So first of all, I think we want to subtract. We want the relative of the camera and the lens. Ooh, okay, cool. So we want this geometry. Now look at that. We are selecting just the points of the point distribute. So first distribute everywhere, and then we just separate out the ones that we're actually interested in that are in view of the camera, right? So this would be the other ones outside, and these are the ones inside. This is neato. So now if I move the camera, look at that. We're only getting points that are actually visible to the camera. Now there's some things we have to tweak here. First of all, if I move the camera really slowly, you can see at the edge over here, if you're looking over here on the edge of the camera view, we get this flickering. So some objects are flickering in and out. And that's an easy fix. All we have to do is go to this lens object here, our square, go into edit mode and bring it out just a little bit. So if I switch on my overlays over here, so we can actually see where that lens object is. You can see, let's bring it out a little bit, and then we get some extra, right? We're still not rendering all of them, just a little bit more, so that now if I rotate, oh, I can't rotate because I have a track 2. Where's the track 2? So now if I move the track 2, can see we're only rendering the particles that we actually want, or that we can actually see. Cool. Next, there is one issue, and Arendelle also shows this in his tutorial, and that is if I bring my track 2 all the way down here, and if I bring my camera down here too, now everything is out of focus because my camera has a depth of field set. Maybe I just want to set this to something fixed, like right here. Is that good? Do we have anything in focus now? Should be. You know what? Let's just switch it off. And I'm gonna switch off the overlays because they're kind of confusing. Maybe I also want to take my icosphere and give it a material so we can see what we're doing. Okay, now let's go to top view and move the camera slightly in, maybe, or out. And you can see we have a problem here. So again, if you look down here at sort of at the border where the camera view ends down here, if I move in and out, you can see we get some flickering of objects. Right? They appear, they disappear, and we can see that they appear and disappear, and we don't want that when we're close like that. So Arendelle, in his video for the dynamic paint, he used an icosphere, an object that he also added to the paint brush around the camera, so that you always have objects close nearby the camera, right? We can do that in geometry nodes as well, and it's actually really simple. So we have our lens object here, which is this little tiny square resembling sort of the lens of the camera. Now all we really want to do is, if that lens object is close to the vertex, then we also include it in our mask for the particles. So this is really easy to do. We just need an attribute math node. Sorry, we need an attribute vector math node. And we want the distance. Where is it? Distance of what? Well, of the position of the vertex on our background to a vector, the position of our lens object, which we have here. And let's put that into something like d for distance. Okay, so now we have a new attribute d, and now we want in an attribute math node, and we want to say if that distance, the d, is less than, well, let's start with 1, then we put it in is close. Okay, now how do we get our is close combined with our is hit into this mask? Well, we really just need another attribute math node. So let me duplicate this one. Let's add is hit coming from here to another attribute called is close, and plug it back into is hit. Now look at that. So let me move my camera. Is it working? I don't know. Let's see. Camera, move camera. No, it's not working yet. Why not? So we have the distance of the position to the lens object. Put that into d. If d is less than 1, then we're setting is close, which is a Boolean, but we can add a Boolean. No, this is not a Boolean, this is a number, but we can add the Boolean and put it in is hit. So this should be working. Why isn't it? Oh, we have to play with this. So let's put some objects like right there. Let me see from side view. If I move the camera, you can see when we're down here close to the ground, we're always getting this circle of particles around here, right? So if I don't, if you know what, if I just use is close here, now you can really see that. So this will be the is close effect, and this is probably a lot. So let's do 1.5. Okay. And then if we take is hit instead, where we added is close and is hit together, then we even have particles close up by the camera here. And if I now move the camera easier like this, you can see we don't get any flickering down here because there's always objects down there anyway, right? And if I move my tracking point for the camera, if I zoom in here, or if you zoom in all the way, you wouldn't even notice that all the rest is never really rendered and is missing. You can only see it if you look at it like this. So this is already really cool, and it's all done just in geometry nodes. So there is one other issue though, and that is, what if I go down really close here and move my camera over here? Now you can see what the problem is. So the geometry of the background is emitting the rays, and we're checking if those rays are hitting our square in the front here, and if it is, then we're including that vertex that emitted the ray in our set for the point distribute. But if I move all the way in here, you can see, of course, the vertices of my background down here, or the ground plane in this case, they're also emitting vertices towards the camera to this point. So this vertex is shooting an array to this point. And since that ray goes 100 meters, it also hits this plane. Now, when I saw that, I thought, oh, now it's getting complicated. How do we fix this problem with having particles rendered in the back here that we don't want or need rendered? But it's actually pretty simple. Let's think about this. So the rays coming from the front here, they go towards the camera. They first hit this plane, our lens plane, and then they, then they're included, right? They're going towards this point, they hit the plane, they're included. But these rays back here, they reach the camera point and then hit the plane. So essentially, they're just too long. Those rays are too long. Remember, here we have the ray length of the Raycast node, and they're always 100 meters. Every ray is 100 meters. But to fix this problem, all we really have to do is make sure that the ray only goes to the point of the camera and not any further. Doesn't make any sense if you're looking this way and the camera ray already reached your sensor, basically. It doesn't make any sense to calculate it any longer than that. And also the rays coming from the back, if they hit the sensor first, we don't care that they actually hit the lens, right? So how do we limit this? Well, very simple. Up here, let me just make some space. We're gonna do another attribute vector math node. And here we're gonna take the distance of the camera location to the position, and let's put that into ray length and use an attribute ray length. And look at that, we have nothing. If I move the camera, we have nothing in the back. In fact, anything beyond this point, like the sensor point of the camera, if we look at it from top view, there's nothing being rendered anymore behind this point, which is exactly what we want. So no matter what we do, if we go all the way back here, we get all of the particles. If we come closer, if we fly over this area here, you can see this works beautifully. We're only rendering the instances, we're only showing the instances. Actually, we're only instancing on the particles or on the points, the distributed points that we actually need and can see. So that is your 100% geometry nodes way of camera culling. This is it. It's really not complicated. All right, this is the Raycast node, and this is just one possibility what this node can do for us. We can use, with just a few other nodes, we can use it for camera culling. The node itself can do a lot more. As you've seen, you can get like the hit position as an attribute, or the distance and the normal of the hit onto that target geometry. Whatever you can come up with, I'm sure you have cool ideas what this node could be used for. Please do tag me on one of my socials. If you liked this video, please give it a thumbs up. Also write a comment down below. If you're not subscribed yet, please consider subscribing. Share the video with other people that are interested in Blender and in geometry nodes. The finished blend file of what we did in this video today is, of course, as always, available over at patreon.com/ChrisP. That's it. Thanks for watching. Chris P out.